So I said all that with the power off on the microphone. No big deal. It says right here. We did parametrics before. Okay. So. It's about as far as it got, huh? Okay, now, one thing is when you're doing your scale for x, make it pi over 2. Pi scale can be 1, it's fine. X scale pi over 2. This would be your window. T min, T max. X min, X max. Y min, Y max. T step, I would make it like 0.1. Something relatively small. 1. So your graph should look like this then. Now, what is this thing here? It's what? It's the unit circle. It's not just a circle, it's the unit circle. Okay? Because it's the graph of cosine and sine. So it is the unit circle. Where this is the graph of sine. So if you hit trace, your values for x are going to go with cosine. Your values for y are going to go with sine. So if I hit pi over 6, for instance, for my t value, so if we go to pi over 6, okay, what's the sine of pi over 6? If you don't have your unit circle out, it should be out. Okay, every day when we're doing the trig stuff, you should have it out. Okay, should be 1/2. Look at that, y is 0.5. The sine of pi over 6 is 0.5. The cosine of pi over 6 is square root of 3 over 2, which is 0.866 as a decimal. Okay? T is pi over 6. T is kind of like, it's just the parameter that we're using. Okay? Yes? Your graph doesn't look anything like that. Why do you have sine and 1? What are you doing? Why did you put that in? Well, you know what? It's not. That was lesson 7.2. This is lesson 7.1. It's right there. Okay. So if I switch graphs then, at pi over 6, we will have that y is 0.5. Okay. So this graph that goes here, the wavy graph there, okay, that's the graph of sine. That's what it's going to look like. All right? So here's what I want you to do. You got your unit circle out, right? Okay, take this sheet of graph paper, and we're actually going to convert that to, okay? So take your sheet of graph paper, and we're going to fold it in half horizontally, okay, or whatever. What is this? Hamburger style, right? Hamburger style of folding, okay? All right? We're doing the hamburger. So you have wider, okay? All right? So it should be 8.5 by 5.5, right? Okay? Okay. All right, a taco. All right, instead of a hot dog bun. Okay, right? This is hot dog and this is hamburger, right? Okay, now, okay, so you fold it in half. Now, in the middle of one of those halves then, or both those halves, okay, when you're looking at it horizontally like this, all right, find approximately the middle, and you're going to put, hold on, don't fold it. You're going to draw an x-axis across here about in the middle and a y-axis about in the middle. Okay, so you're going to make your coordinate plane in there, all the way across, up and down, about right through the middle. So you have a T right through the middle of this piece of graph paper on both sides. Okay, on both. Look at it like this. So you're going to put it here, and then the bottom, which will be the other half of it, you're going to do the same thing. Okay? All right? Right about approximately in the center. All right? So you've got, here's my front sheet of graph paper. I folded it on one part. I'm going to put an x and y axis. On the other part, I'm going to put x and y axis. We're going to graph sine and cosine. Okay? Do the same thing on the other side. Yeah. Does not have to be perfect. Okay? Doesn't have to be perfect. Now, vertically then, you're going to draw a scale, go 0 to 2 by 0.5s. Okay? Vertically, we're going 0 to 2 and 0 to negative 2 by 0.5s. Okay, so your y-axis will be that. Yep, on both of them. Do not label the x-axis. Yep, so it'll look just like this. just go to 2. What's the max value for sine? Max is 1, so basically we're just going above where the max. So okay, some of you are making it bigger than necessary, but that's all right. Okay, now along the x-axis, all right, we're going to do radians. All right, so every 3, okay, is going to be a pi over 2. So if I go 1, 2, 3, I'm putting pi over 2. And then 1, 2, 3, and I have pi. 1, 2, 3, 3 pi over 2. And 1, 2, 3, and 2 pi. All right, and then do it with the negatives. All right, so we're going to have a graph that goes from negative 2 pi to 2 pi. You must do it exactly the way I'm saying, or you won't have enough room. We're not in the book, are we? Okay. Okay. Now, all right, so make sure you have it for both. All right, so we're going to graph on the top one up here. We're going to graph sine. Okay, this is going to be sine of t. All right. Now, at 0, what is sine? We're looking right at our unit circle. Sine of 0 is 0. So I'm going to put a dot right in the origin. Okay. Now, if I've gone 3 marks here to get to pi over 2, how much is each mark? It's 1/6 of pi, right? It's pi over 6. Okay. So what's the sine of pi over 6? 1/2. All right. So at the first mark here, which would be pi over 6, I have 1/2. Each mark represents pi over 6. So the sine of pi over 6 is equal to 1/2. Okay. What's the sine of pi over 3 then? Okay, what's that as a decimal? Anybody know? Okay, it's 0.866. So 0.866 then would be approximately here. Okay, almost to the top, almost to 1, but not quite. All right, what's sine at pi over 2? 1. Okay, so at pi over 2, I've got 1 here. All right, so we're going by 6, continuing on. All right, so how about 2 pi over 3 then? What is it? Okay, 0.866 square root of 3 over 2. At 5 pi over 6, what is it? 1/2. At pi, it is 0. Okay, so right now I should have those dots on my graph. Okay? All right, is everybody okay with that? Yep. No, we did not. I don't think we did. We didn't. Did we? Maybe we did do it in your class. Was that first semester? Second semester? Okay, we probably did then. All right, now, 7 pi over 6, what is it? negative 1/2. Four pi over 3. Negative square root of 3 over 2. 3 pi over 2, what is it? Negative 1. And then we're going to do the same thing going back up to 0. So we just used the unit circle to make the graph of sine. Okay? And what happens if I go around again? I get the same thing, right? What happens if I go clockwise? Do what? Yeah, it's going to do the negative 1. So basically what's happening is we're going to take that thing right there. See if I can do it. I can't. If I take this right here, all right? No, it took too much. I'm not going to be able to do it. So basically what we're going to do then is we're going to take this whole thing then and we're going to move it over here. Oops. Yep, you want it there too. And then connect your dots. And there's the graph of sine. Now, we know what the shape of it looks like now. Okay? So you really only need some specific points to be able to redraw this. Okay? The only points I need to redraw this now are the axes, or all the pi over 2's. Okay? So if I know 0, pi over 2 pi, 3 pi over 2, and 2 pi, if I know them, I can draw the graph of sine. Okay? Because all it is a nice wave action going on. This is called a periodic function. That means it repeats itself. And this repeats itself how often? Every 2 pi. So this has a period of 2 pi because it repeats itself every 2 pi. The domain is what? All real numbers. And the range is between -1 and +1. Okay, there's the graph of sine. Now, in that bottom half of that sheet, we're going to do the graph of cosine. So look at your other one that you drew. Okay, and we're going to do cosine there. And then we're going to look at the two and say, okay, this is how I know a graph is sine. This is how I know a graph is cosine. Okay, there's a little bit difference about them, but not much. All right, so at 0, what is cosine? 1. Okay. At pi over 6, what is cosine? All right, square root of 3 over 2, right? Okay. And at pi over 6, or pi over 3, what's cosine? You all right back there, Sierra? What's the matter? Unit circle's messing you up?
Because you keep saying, I don't know, I'm not quick enough with what you're saying. I got that one.
Awesome. Okay. Cosine of 0 is 1.
Oh, so we're going by this. Oh.
Okay. So we're doing the x values now.
Alright.
All right. We're good. Okay. Cosine of pi over 2 is 0. Okay. So, all right, finish up the graph of cosine. Yep, connect the dots. So really, all I need then to be able to draw these graphs is all the pi over 2's. 0, pi over 2, pi, 3 pi over 2, 2 pi, because that tells me what my graph is going to look like. The period is 2 pi also. The domain is all real numbers. And the range is still between -1 and 1. Now, why is this important? It's very important because you need to understand what the two graphs look like. So first of all, they look very similar, don't they? Okay. Now, so if I take the graph of cosine, and I go up here to sine, so here's the graph. Oh, my axes are different. I forgot they were. Okay. But if you notice, what's the difference? It's just been what? Okay, moved over. So the graph of sine and graph of cosine actually look the same, except for they're shifted. Okay. So they are very similar. Right? Now, looking at the two of them together, what is one thing you could look for and say, okay, if I see this, I know it's sine and not cosine. Or if I see this, I know it's cosine and not sine. Okay? All right. Savannah. Okay. So sine goes through the origin. Okay? All right. And cosine is going to go, it's going to be at the max on the y-axis. Okay? Or the difference is that sometimes you might see the reflection, which means then that sine will still go through the origin. It's just that cosine would have a min on the y-axis instead of the max on the y-axis. Okay, if we did vertical reflection. Okay. All right. So those questions from your sheet. Okay. Now, question was is that, well, now this graph here doesn't look the same as the same axis, right? But I told you there's 5 important numbers, okay? 0, pi over 2, pi, 3 pi over 2, and 2 pi. If you can graph them, then you're doing pretty good. So here it says state all the values in which sine is equal to 1. So if I want to draw the graph, I'll do the graph of sine, and I'll label them, oops. The reason there's only 4 on each side is because that's all I need. Because those give me my maxes, mins, and zeros. So the graph of sine then going to look like this. And goes on. Now the question is here, state all values when for t when sine of t is 1. So when does sine equal 1? Sine equals 1 at pi over 2, right? Okay. Now we said that it's periodic. All right, so let's look at our unit circle along with the graph at the same time. When does sine hit 1 again? Where at? Let's go positive. When does sine hit 1 again? Gallery. At 5 pi over 2. In other words, pi over 2 plus 2 pi, right? Because if we look at the unit circle, come on, there we go. Okay. We look at the unit circle, sine is pi over 2, or is 1 at pi over 2, and when I go all the way around the circle again to that spot, it's 1 again, isn't it? Or if I go clockwise and go all the way around the circle again, it's at pi over 2, but it's 1 there again, isn't it? So how far do I have to go to get to where sine is 1 again? Okay, I have to go around the circle once, right? Which means I have to add 2 pi, and then I could add 2 pi again, or I could subtract 2 pi, right? Or do it over and over again. So then that's where we're going to say that t is equal to pi over 2 plus pi n, or sometimes they use the letter k. Doesn't matter what letter you use. But I'm going to say pi over 2 plus pi n. Oh, excuse me, that's not pi n, is it? It's 2 pi n, where n is an integer. Because integers reflect both the positive and the negative. Okay? All right. Now, number 2. When does cosine equal negative 1/2? All right, so let's draw the graph of cosine. All I need is those wonderful numbers, those main points. Okay. Now, I want to know when it equals negative 1/2. So I'm going to draw a line through here at negative 1/2. All right, I've got that black line. I'm going to change that to, oh, how about orange? So when does cosine equal negative 1/2? Well, which 2 numbers do I want to look at? Which 2 on that graph that I can see, where do I really look at? At where? Not pi over 2. Well, the ones that are close to that, right? Okay. Not pi and 2 pi. But we're looking for where this line at negative 1/2 intersects the graph, right? So it intersects the graph here and here, right? Which from pi over 2 to pi is in which quadrant on our unit circle? Second quadrant. Between pi and 3 pi over 2 is in the third quadrant, okay? So where in the second quadrant is cosine equal to negative 1/2? Okay, at 2 pi over 3. Okay. In the third quadrant, where is it equal to? Okay, at where in the third quadrant? Now, has everybody found them? Okay, second quadrant, cosine is x, right? Okay, so I go over the second quadrant, cosine is negative 1/2 up here at 3 or 2 pi over 3, right? 2 pi over 3, cosine is negative 1/2. Down in the third quadrant, cosine is x, cosine is negative 1/2 down here, which is at 4 pi over 3. Okay? Yep. Look where x is negative 1/2. Okay? And if I look at my graph, if I look at the graph, where has it intersected at? Intersected between pi over 2 and pi, which is the second quadrant, between pi and 3 pi over 2, which is the third quadrant. Okay? Now, are these two related by anything? Okay, they're pi over 2 apart, right? No, they're not. Or are they? 2 pi over 3 and 4 pi over 3. Those differ by 2 pi over 3, right? But really, but if I went another 2 pi over 3, would be where cosine equals negative 1/2 again? No. Okay? Because what do I have to do to get to other places where that's true? We would have to go way back here and here, right? How do those two numbers differ from the first two I found? Gallery? They differ by 2 pi because I'd have to go all the way around the circle again to each of those individual spots to find that answer. So this means I have to do what to 2 pi over 3 and 4 pi over 3? You have to add 2 pi n. And that's where n is an integer. Okay, we okay with that? So whenever we're doing these then, okay, you've got to differ by, for sine and cosine, to get to that same spot, I have to go all the way around the circle again back to 2 pi. So I have to add 2 pi to anything to get back to there. All right? Okay. Now, turn your graph paper over. Okay, now, with this one, let's look at the important features first and kind of narrow it down a little bit so make it easier for your graphing. Now, where are the important elements on the graph or on the unit circle? What parts of the unit circle help me the quickest to do graphs? Okay. All the axes, right? X and Y axis. Okay. All right. So let's look at the x-axis at 0. What is tangent of 0? Okay, 0. All right. So we have at 0, it's 0. Okay. How about pi over 2? What's the tangent of pi over 2? Okay. How do I represent undefined on a graph? With what, Max? A vertical line. So I'm just going to draw a vertical line. Okay. Maria says it's an asymptote. And an asymptote then has what? It's a vertical line, but it's dotted. Okay. Right. Because it's undefined there, it's a vertical line. All right. Well, the graph doesn't go through that. Okay, how about pi? What is it? 0. Okay. 3 pi over 2? Oh, there's another asymptote there. It's undefined. How about 2 pi? 0. Okay. So what can you tell me then? The graph is not so special. Okay? All right. So what else could I add on there really quick, really easily? Well, let's just worry about what we see right now. What? It's equal to 1? Well, it is, but somewhere. But we're not going there yet. Okay? Gallery? No, it's not like a quadratic. But all the pi over 2's, at negative pi over 2, what is it? Okay, it's undefined. How about negative 3 pi over 2? Okay, so I got my vertical asymptotes. I have asymptotes at all of the pi over 2's, right? Okay. So since it's undefined there, how do we represent that when we're talking about domain? Okay, all real numbers except. So we'll get there in a second. Okay? All right, now we've got at all of the pi's, it is 0. So we need to work in between them. All right? Okay. Now, all right, let's look at our numbers at pi over 6, like we did with sine and cosine. What's the tangent of pi over, or wait a minute. Look in the first quadrant. What's the easiest number in the first quadrant to work with? 1. Okay, and that's at pi over 4, right? Where's pi over 4 at on here? Okay, halfway between them, right? So halfway between them, I'm at positive 1. Okay. Okay. So what if we go backwards then to negative pi over 4? What is tangent? So go clockwise down to negative pi over 4, and tangent is equal to what? Okay. All right, so tangent is negative 1 at, so the graph is actually going to look like this then. It almost looks like a cube. That's right. It almost looks like x cubed. Right? And guess what? It's going to do that in every single one. You can't do that in yours? Yours won't copy and paste? Oh, that's a bummer. Yeah? Okay. All right, so our, okay, period. Let's talk about period again. Tangent. How often does tangent repeat itself? Okay, Sierra, how far is it from pi over 2 to 3 pi over 2? 1 pi. Okay, how far is it from negative pi over 2 to pi over 2? So the period is equal to pi. So if you look at your unit circle, if you look at the top half of your unit circle, the bottom half of the unit circle repeats tangent. Okay. The first and third quadrant are exactly the same for tangent. The second and fourth quadrant are exactly the same for tangent. Okay? All right. So, the domain for tangent. T cannot equal where it's undefined, right? And it's undefined at all forms of pi over 2 plus pi n. Okay? Because the period is pi, so every time I go pi from pi over 2, it is undefined. Okay? The range is what? All real numbers. Goes on forever. Okay, now, I got 2 minutes. All right? Okay, so let's just look at, we're going to answer number 3 here. We're not going to redraw the graph though, okay? But when you redraw the graph, okay, to redraw tangent, all I need to know is where the asymptotes are, -1, 0, and 1. Okay? I can draw all of them just from knowing one of these. I can take one of them and redraw it. Okay? But question is, when does tangent equal 1, right? Okay? So tangent equals 1 at pi over 4. And then how far do I have to go to the next time it happens? I have to go pi because that's what our period is for tangent. So my answer here is going to be t equals pi over 4 plus pi n, not 2 pi, but just pi n, where n is an integer. Okay, so tonight